Good morning and welcome to Thursday's Maths. So all this week we've been looking at pie charts and we've been linking pie charts to fractions and percentages. So we've finished our work on pie charts now and we're now going to start looking at line graphs. So we're going to look today at interpreting line graphs and then tomorrow is going to be about drawing our own line graphs. Right, let's get started. So here is our discover for today, and here is a line graph. So it's nice and easy to remember the difference between a line graph and a bar chart. A line graph is a line and a bar chart is bars, okay? So it's nice and easy to remember which one's which. A bar chart shows things that are separate, okay? So it might ask something like, what is your favourite colour? So there'd be a bar to show red, a bar to show yellow, a bar to show green, etc. Whereas a line graph is usually numbers because it's continuous. So you can have something that happened at 5 o'clock, 6 o'clock, 7 o'clock, but you can also have something at 5:30, 5:15, 5:10. And that line graph shows the continuousness of this data, whereas a bar chart shows things that don't continue. There's no kind of data in between red and yellow. They are separate things. So we are looking at line graphs, which shows continuous data, which is often time, temperature, it might be distance, or it might be population. So first things first, whenever you get any kind of graph or chart, the first thing to do is read the labels. What is this graph trying to show you? So the title says morning temperatures in the city. I can see that the y-axis, which is the one that's going down, is showing temperature. And I can see actually that it's gone from positive, and then I can see actually it's got a 0 and then it's going to negative. And I can see that along the bottom, the x-axis would be time. Okay, and I can see that actually the labelled x-axis is actually in the middle. We've kind of got two quadrants here. So my second thing to do is start looking at the scale. So once I know what this is showing me, I then start looking at the scale. So if we look at the temperature on the y-axis, it's going 0, 2, 4, 6. Okay, so that tells me that each big square is going up in 2. So if it was halfway across a square, that would be how many degrees? 1, because half of 2 is 1. So halfway between 0 and 2 would be 1. Halfway between 2 and 4 degrees would be 3 degrees. Right, if I look across the bottom then, I can see it's going 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock. And there are two intervals, two parts in between 5 o'clock and 6 o'clock. So there's a difference of 1 hour. The whole is an hour, and we're splitting it into two parts. So that tells me that each line represents half an hour. So it's going 5 o'clock, 5:30, 6 o'clock, 6:30, 7 o'clock, etc., etc. Right, now we are confident with what our graph is showing us. Let's have a look at the line. Let's have a look at the data. So I can see that it was very cold at 5 o'clock, and then I can see the temperature has increased throughout the morning. And I can see that because my line is going in a diagonal up towards that top right-hand corner, or it's kind of a bit of a curve. So it started at -6 at 5 o'clock, and then it's going up to 2 degrees at 8 o'clock. So question A is, how much did the temperature increase between 6 a.m. and 6:30 a.m.? So you know where 6 a.m. is. Go down until you hit the line and then read off the y-axis. Do the same for 6:30 because you know the scale, should be able to know that now. And then what's the difference? And then B is an estimate. Estimate at what time the temperature reached 1 degree. So 1 degree C, what time, and it's going to be an estimate, did the temperature reach 1 degree C? Right, pause the video, have a go. Okay then, answer time. So I wanted to know the difference between the temperature at 6 o'clock and 6:30. And I know that this was half an hour, so I know that that's 6:30. So first of all, I'm going to go along till 6 a.m. Then I'm going to go down until I hit the line. Okay, so there's the data point there. Now, obviously, normally, if you have a ruler, you would use a ruler. I don't have a ruler at home, which is a bit of a pain for this line graph lesson, but it's also a bit difficult to use on a computer anyway. So it's not the best I've ever drawn it, but it's in between -4 degrees and -6 degrees. It should be about halfway, which would be -5 degrees. There we go. Right, now I'm going to look at 6:30. Also, 6:30 is nice and easy because it hits the line on the line graph on a grid, which is good. So I can go across and I can see that it was -2 degrees. So what's the difference between -2 and -5? Well, think about it. What's the difference between +2 and +5? So if we started at -5, we'd go -4, -3, -2. So the answer would be 3 degrees difference, which is the same as the difference between +2 and +5. So for 1A, you should have had 3 degrees. Right, B then. It wanted you to know, to estimate, what time it got to 1 degree. Right, so I'm going to find 1 degree. So if this is 0 and this is 2 degrees, it's going to be halfway. So, ooh, dear, that's not very good. So again, you would use a ruler. Right, so it's here. So I then go down, ooh, there we go, to the x-axis. So I can see that it's in between 7 a.m. What would this one be? 7:30. So it's in between 7 o'clock and 7:30. It's not halfway. If it was halfway between the two, oh no, I got rid of it. If it was halfway between the two, that would be, what's halfway between 7 o'clock and 7:30? Well, that would be 7:15. But I can see that it's before that. So I would estimate it to be about 7:10. But if you got between 7 minutes past and 13 minutes past, I'd give you a mark. But I'd estimate it's about 7:10. Okay then, think together time. So we have a graph. And this graph shows the height at which a balloon floated between 13:00, what time's that? 1 o'clock in the afternoon, because you take away 12. And 17:00, what time's that? Take away 12 hours, would be 5 o'clock in the afternoon. So it's the height a balloon floated between 1 o'clock and 5 o'clock in the afternoon. So before we even look at the question, I'm going to gather all the facts. What do I know about this graph? Well, I can see that we've got height on the y-axis and we've got time on the x-axis. I know what it's showing me because I've read the labels. Now I want to work out my scale. So if I look at height, first of all, I can see it's going up in 200, 400, 600. So it's going up in 200 each time. But that there's actually an interval in between 0 and 200. So what's halfway between 0 and 200? 100. So I know that actually each little grid line is actually worth 100 metres. Then I look at time along the bottom. So that's going from 1 o'clock to 1:30 to 2 o'clock to 2:30. So that tells me that each big interval is half an hour. But again, that's made up of 2 parts. There's a grid line there. So 2 parts. So half an hour is divided by 2 would be 15 minutes. So actually each one of those little grid lines is 15 minutes. So go 1 o'clock, 1:15, 1:30, 1:45, 2 o'clock. Right, now I'm going to look at my question. Now I'm confident. How long did the balloon remain above 500 metres? So for this question, you need to find out what time did it go above 500 metres, what time did it go below 500 metres, and how long was that period of time? Have a go. Okay then, answer time. So I wanted to know how long the balloon remained above 500 metres. So I've gone up the y-axis, I've found 500 metres, which is halfway between 600 and 400, and I've drawn a perfectly straight line with a ruler, as you can see, all the way across the graph. Unfortunately, this doesn't let me draw straight lines on it, which is a little bit tricky. So I've had to do it freestyle, so yours will obviously be much straighter than this. Right. I now want to find out what time it went above 500 metres. So if I go down to the x-axis, I can see it went above 500 metres at 1:30. If I then go down here, so it was just past that grid line, I can see it's in between 4 o'clock and 4:30. It's just past this grid line. Well, each grid line was 15 minutes. So that's 4 o'clock. That's 4:15. And it was just past that. So I'm probably going to say it was 16:20. There we go. So how long did the balloon remain above 500 metres? What's the difference between 1:30 and 4:20? So you could have done this in your head, but I've done it on a number line, just like we were doing the other week when we were looking at time and working out the difference between 2 times. So I've added half an hour to get to 2 o'clock. It's always easy to go to your nearest hour. Then I've added 2 hours on to get to 4 o'clock, or 1600. And then I've added 20 minutes to get to 1620. 2 hours, add 30 minutes, add 20 minutes is 2 hours and 50 minutes. This is obviously a bit of an estimate because it was tricky to see what time it went below 500 meters. So if you've got kind of 5 minutes either way, I would give you the mark. Well done. Right then, number 2. So first things first, gather all the facts you know about it. Read the labels. What is this graph showing you? Then have a look at the scale. Can you work the scale out? And then have a go at answering the questions. Okay, so this is about estimating the temperatures. Okay then, let's have a look. So this is a graph showing a patient's temperature. Got the temperature down the side, and we've got the days and the time on the bottom axis, on the x-axis. And I can kind of see that his temperature goes down, then it goes back up, then it goes back down again, and a little bit up at the end. Right, I'm going to start looking at my scale. So here it goes. 36, 37, 38, 39, 40. Right, so it's just going up in 1 every time. So if the difference between 36 and 37 is 1 degree, what's this little halfway point going to show them? What's each grid line going to be showing? Well, it's going to be showing half a degree. So if that's 36, that's 36 and a half, 37, 37 and a half, 38. Right, let's have a look down the bottom then. So this is all day 1. So 0 o'clock is obviously midnight, 6 o'clock, 12 o'clock, 6 o'clock in the evening, and then back to midnight. So what's the difference between in one big interval? Well, 6 hours. So then what's each grid line worth? What's half of 6? 3 hours. That's 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock. Okay, right, let's have a look at our first question then. So at 9 o'clock on day 1, what was this patient's temperature? So I'm going to go across. I know that this is 9 o'clock because it's 3 hours after 6. I'm going to go all the way up till I hit the line, which is about here. And then I'm going to get my pen. And I'm going to draw. Ooh, not the best drawing. I do apologise. So I can see it's in between 38 degrees and 39 degrees. But I can see it's also above this halfway line. This halfway line was 38.5 degrees. Can also see that actually if I drawn it properly, it's actually halfway between 38.5 and 39. Ooh, so it's definitely going to be a decimal. What's halfway between 38.5 and 39 degrees? Think about if we were splitting this into 4. What would it be? What's 1 divided by 4? Well, it would be 0.25, which is the same as a quarter. So that would be 38.25, 38.5. So this one would be 38.75. Well done if you got that right. Because it is an estimate, I'd give you a degree either way. Right, now we need to do 9 o'clock on day 2. So here's day 2. There's midnight, there's 6 o'clock, there's 9 o'clock. So I'm going to go up. I'm going to try and draw it. Ooh, a bit better this time. Okay, so this time it's in the same place, but it's just 1 degree below. So it's bigger than 37 degrees, it's less than 38, and it's halfway again between 37.5 and 38. So this one's going to be 37.75 degrees. Last one then for this question, 9 o'clock on day 3. Well, there's day 3, there's 9 o'clock. Right, so this one is just above this grid line here. So it's just above 37 degrees. Remember, this is 37.5. This is 37 degrees. So what might be a good estimate for this temperature then? So just above 37. So I'd probably say about 37.1 degrees, or I'd give you 37.2 as well. Any higher than that? Probably not, because if this is 37.5 here, and this is quite a long way below that. Okay, so about 37.1, 37.2. Right, well done. Okay, here is question 1. I'm going to give you all the questions today and then I'll go through all the answers together. Here is question 2 and 3. And here is the challenge if you would like to have a go at it. Right, pause the video and then I will go through your answers. Okay then, answer time. So for number 1, first of all, let's work out what this graph is showing us. Well, it's talking about the temperature of tomato sauce cooling in the freezer. Very interesting topic. So here's the temperature. And I can see it's going up in 2, so that tells me each little line is worth 1 degree. Here is the time going across the x-axis, so I can see that it's going up in half an hours. Oh, there you go, I hope you can see that. So from 2 o'clock to 2:30, and I can see that it's got 1, 2, 3 little gaps. It's got 3 parts making up the whole. So the whole would be half an hour, and there's 3 intervals. So if the whole thing's half an hour, there's 3 intervals. Each interval should be 10 minutes. So you'd have 2 o'clock, 10 past 2, 20 past 2, 30 past 2, or half past 2. So question 1 was, what temperature is the tomato sauce at the following times? So 2:30, nice and easy. You go straight up. It's on a grid line. Go across. In between 14 and 16 would be 15 degrees. Next one, 5 o'clock. So go along to 5 o'clock. Go down. Again, nice and easy. It's on a grid line. Go across. Right, make sure you get the right way round. If this is -2 and this is -4, in the middle would be -3. Right, B. How much does the temperature decrease between 2 o'clock and 5:30? Well, at 2 o'clock, it is 19 degrees. And at 5:30, right, 5:30 is in between -6 and -5. So it's -5.5. I've written these down here. So what's the difference between 19 degrees and -5.5? Well, you can do it either ways. You can start at -5.5. What would you have to add to -5.5 to get to 0? Well, you'd have to add 5.5. And then add 19 would be 24.5 degrees. Or you could start at 19. I'll draw it on a little number line so you can see it. Remember, you've always got to go through 0. So you'd have to take away 19 to get to 0. And then you'd have to take away 5.5 to get to -5.5. So it would have been, to add these together, 24.5. Or you could have gone the other way, add them. Didn't matter either way. Next one. At what time is the temperature of the tomato sauce 0? Well, here is 0 degrees C, so we go across. So it's in between 4:30 and 5 o'clock. That's 4:40. That's 4:50. So I'd probably go for about 4:48. And the last one for this question, estimate the temperature of the sauce at 5:45. Right, so that's 5:30. That's 5:40. And that's 5:50. So 5:45 is in the middle. So if I go all the way down, it's about there. Follow this along. It's about here. So in between -5 and -6, and more towards the -6 way. So I would say about -5.75. But if you had -5 to if you had -5.6 to -5.9, I'd give you a mark, because it is estimating a lot of these. Right, number 2, use the graph to estimate the population in each year. So I've got the population, I've got the years down the bottom. 1995. In fact, let's look at the scale first of all. Right, so I can see that it's going up in 100,000s. So what's a little halfway point then? That's going to be 50,000, isn't it? So 1995 is in between 50,000 and 100,000. So I would go for about 70,000 to about 75,000 for that one. 2005, there's 2005, go up. And it's in the middle here between 200,000 and 250,000. So I'd say it's about 200,000 and 200. Around that. So if you got about 100,000, if you got about 100 either way, I'd give you the mark. Right then, next one. So this graph is showing you the distance and time for a cyclist in a road race. You've got time along the bottom, distance up the side. So you know that each one's 20, so halfway is going to be 10. Here you've got between 30 and 60. There's 30 minutes, and again, it's split into 3 bits. Each bit's going to be 10 minutes. So how far did the cyclist race? Well, this is him at the start, and this is him at the end. How far did he get? He went 110 kilometres. Right, these next bits were a little bit tricky, but it was basically asking you to do it almost in order. So, the cyclist slowed to climb a steep hill between what time? So, here, he's gone a very long distance in a very short time. So, this actually means he was going quite fast. Here, he's not travelled any distance. So, this actually means he's stopped. Now, here, between 30 minutes and 90 minutes, you can see this is kind of one of the flattest parts of the graph. And that's because he's taking a very long time, but he's not going very far. So the answer for the first bit should be 30 minutes to 90 minutes, because this is actually when he was going the slowest, because he wasn't travelling very far, but it was taking him a long time. The next one then, the cyclist rested. So he rests here and he rests for one whole grid, which we know is 10 minutes. So he rested for 10 minutes after 120 minutes of racing. Right, after how long had he completed half the distance? Well, the distance was 110. Half of 110 is 55. So there's 50, there's 55. Go across, just about there. So just over 100, so about 102, 103 minutes. And when did the cyclist race the most quickly? So that's when it's the steepest. Well, that's 120, that's 130. So between 130 minutes and 160 minutes. Well done if you got those right. They were a bit tricky, those sentences. And the last one was the challenge. So 300 runners started a 12-mile race. So you've got numbers of runners on the y-axis, the distance along the x-axis. What fraction of runners completed the race? Well, you can see at 12 miles, it's gone down to 100 runners. So it's gone from 300 runners to 100 runners. 100 out of 300 is the same as 1/3. Right, next one then. What percentage of the runners completed fewer than 6 miles? So if you draw up to where it was 6 miles and go across, it shows you that about 210 of the runners completed 6 miles and then carried on. So that tells me that 300 take away 210 is 90 runners. So there was about 90 runners who didn't go further than 6 miles. They dropped out before that. So now I need to work out 90 out of 300, what would that be as a percentage? Well, if I write it as a fraction, first of all, so 90 over 300, divide it all by 3 would be 30 over 100. 30 over 100 is 30%. Right, next one, C. This took a little bit of working out, this one. So, estimate how many runners completed at least 75% of the race. So, as you can see on my graph, I've written where 100% was, obviously at the 12 miles. Then I've gone halfway between 6 miles, which is 50%, and 12 miles, and I've worked out that must be 9 miles. So 9 miles is 75% of the race. If you then go up to where the line and the data is drawn, you can see that there is about 180 runners who completed at least 75% of the race. Okay, it's about 180 runners, and you can see that on the y-axis there. So then you need to work out that as a percentage or as a number. So 100 and yes, so really I think you could have got away with 180, but the answer book wants you to have it as a percentage. So 180 out of 300 is the same as 60 out of 100, which is 60%. But if you'd put 180 runners, I'd give you the mark as well, because I don't think that's very clear. So either 180 runners, which is 60% of the runners. Right, well done. That last one was quite tricky. Really good work today, and I'll see you tomorrow. Bye.